Hi everyone, and welcome back. I recently found a few Lowland Wemos D1 Mini Pro boards in my workshop and decided it was time to revisit the ESP8266 platform after a few years. I was pleasantly surprised at how much the software ecosystem has improved. Starting with a clean Windows installation, I had the board up and running in just a few minutes. In this video, I'll show you exactly how to install the required software, configure the Arduino IDE, and upload your first program to the board. All download links are available in the video description. For this demonstration, I'm using Arduino IDE version 2.3.10 and the Silicon Labs USB to UART, VCP driver version 2.1.neo.x and Windows 11 home version. Let's get started. Step 1. Install the Arduino IDE. Open your browser and navigate to the official Arduino software website using the link in the description. Download the latest version of the Arduino IDE for your operating system. Once the download is complete, run the installer and accept the default installation options. On my Windows 11 home system, the installation completed without any issues. Step 2. Install the USB driver. Connect the Wemos board to your computer using a data-capable micro USB cable. A quick warning here. Many inexpensive micro USB cables only provide power and do not carry data. If no COM port appears, the cable should be your first suspect. Open Windows Device Manager and expand ports COM and LPT. If Windows cannot identify the USB interface, you'll need to install the correct driver. Many ESP8266 development boards use the CH340 USB to serial converter, while others, including this Wemos D1 Mini Pro board, use the Silicon Labs CP210X USB to UART bridge. In my case, Device Manager indicated that the CP driver was missing. Download the CP210X VCP driver from the Silicon Labs website using the link in the description below. Extract the zip archive and run the 64-bit installer using the default installation settings. Once installed, reconnect the board and verify that a COM port now appears in Device Manager. Step 3. Install ESP8266 board support. The Wemos D1 Mini uses an ESP8266 microcontroller, so Arduino IDE needs the ESP8266 board package before it can compile code for the board. Open the Arduino IDE. Go to File, Preferences, locate the additional boards manager URLs. Click the icon on the right to open the list of community-supported board package URLs. Scroll down until you find the ESP8266 community entry. Important: copy the URL only. If you click it directly, your browser will simply display the JSON package file. Paste the copied URL into the additional boards manager URLs field and click OK. Next, open the boards manager from the left-hand toolbar. Search for ESP8266. Locate ESP8266 by ESP8266 Community and click Install. The installation usually takes a minute or two. Step 4. Configure the board. If you've disconnected the board, reconnect it using the same USB cable. Now configure the Arduino IDE. Navigate to Tools Board, ESP8266. Click on Boards and select the Lowland Wemos D1, R2 and Mini. Next, go to Tools Port. Select the COM port assigned to the board. This should match the port shown earlier in Windows Device Manager. At this point, the IDE is fully configured. Step 5. Load the blink example. The onboard blue LED on most Wemos D1 Mini boards is connected to GPIO2, which Arduino identifies as LED built-in. Rather than writing code from scratch, we'll use one of the built-in examples. Go to File, Examples, Digital, and open Blink without delay. This example demonstrates non-blocking timing and is generally preferred over the basic blink example for learning good programming practices. Step 6. Upload the sketch. Click the Upload button in the upper left corner of the Arduino IDE. The IDE will compile the sketch and begin programming the ESP8266. During programming, you'll see progress messages in the console, and the blue LED on the module may flash rapidly while the firmware is being written. After a successful upload, the board will automatically restart. The onboard LED should now blink once every second, confirming that your Wemos D1 Mini is correctly configured and communicating with the Arduino IDE. Congratulations! You've successfully installed the Arduino development environment, configured ESP8266 support, and uploaded your first program to a Wemos D1 Mini Pro. From here, you can start exploring Wi-Fi networking, web servers, MQTT, IoT projects, sensors, displays, and much more. If this video helped you, consider subscribing for more electronics, embedded systems, and DIY engineering projects. Thanks for watching, and I'll see you in the next one.